Okay, this lecture is on grades and we have to analyze grades on using stiffness method. This is lecture 15. I believe it's too fast, but we have to. I think you are actually well acquainted with all the concepts, grades, frames, and you are a graduate student, so concepts are easy to grasp for you. That's why, and we have to conclude the course in within this month, and then we have exam, and that's why we have to be fast. Educations are coming as well. Okay, this is great, and I think I have given you the concept about ki of a grade. So a grade, for example, this is a grade. A member is in x direction, another member is in z direction, and we have some sort of loading on it. The basic thing is that the ki of a grade would be equal to 3j minus r. Now we have three joints, so that's why we have written 3 here. Why these are 3? Because we have got 3 equations in a grade. The basic concepts of a grade remain same, whether it's flexibility or stiffness. Sigma fy, and you should tell me it's sigma mx and it's sigma mz. There is no sigma fx because there is no loading in x. There is no sigma fz because there is no loading in fz. Number of support reactions, 3 here and 3 here. So it comes out to be 6 in total, and I have 3 degree of freedoms. I can also find the ki using the inspection method. Because this is fixed and it can resist all 3 reactions, so it has no degree of freedom. The maximum possible degree of freedom in a grade for any joint is 3. In y direction, it cannot resist moment in x direction, it cannot resist moment in z direction. However, a fixed support has been provided, so it can restrain all that degree of freedom. Same is the case here. However, this is a joint, so it cannot restrain a moment in x, a moment in z, and a reaction in y. It can be upwards or downwards, and this would be my ki. There are no axial deformations because this is a moment, and moment cannot be axial deformation. Yes, it is axial deformation if there was a column here. If there was a column here with a fixed support or any support, then this would have been an axial deformation for that, but that would be a space frame and no more a grid. In a grid, we don't have a y member, so we have to account all these 3 degree of freedoms. So degree of freedom in a space frame can be reduced by applying the concepts of axial deformation. Total ki minus number of members gives us ki modified, and that is, we are ignoring the axial deformations. Here there is no such concept because there is one axial deformation, and that is in y direction, and that has no column. Okay, the thing is, the degree of freedom is d1, d2, d3. Directions may be arbitrary. I mean, you can select d2 as in this direction, d3 in this direction, and d1 in this direction. It's totally up to you. Finally, in the next stage, sorry, not finally. So this is my D matrix, d1, d2, d3. Then I have to another thing is ED matrix. So if we are done with D, we have to find the ED matrix. So ED matrix is actually corresponding to D matrix. So you have to construct ED matrix accordingly. So ED matrix, for example, in this case, all terms should be 0 because there is no applied moment. For example, in this question, I have applied moment of 10 kip-foot here. Now in that case, it is in the same direction at D2, so this would become plus 10. And what if I have applied load here and it's equal to 30 kips? Now it is in the same direction at D1 as D1, so this would be D1, 30 plus 30. And what if I have applied moment in this direction, in Z, and it is opposite to D3 and its magnitude is 20 kip-foot? Now that would be minus 20. So now you should recall all your concepts from BSc knowledge, and it's very easy. In this case, AD is 0 because there is no applied moment here, no applied load here at the joint. Next stage is to find the fixed end moments, and fixed end moment becomes all fixed end moments come in ADL matrix, and ADL matrix means action due to load. Now in that case, I have to make all the supports fixed, all the joints as fixed, and you should recall this concept that if you have to compute the fixed end moment for this, then this should be anti-clockwise, this should be clockwise. So here I'll be applying anti-clockwise and this should be clockwise. Here again this should be anti-clockwise and this is anti-clockwise. Why I'm applying in X direction? Because this is Z, the loading is in Y. This is only one possibility. Loading can only be in Y. So Y and Z, and it gives us X. Similarly, this should be clockwise because this is clockwise. If one is anti, the other should be clock. If this is anti, this should be clock. So clock in X is like this. And counterclockwise in X is like this. Counterclock in Z, Y, because loading is in Y, this is X, so this is Z. Okay, the loading here is 10 and 10 kips, and this is 10 feet and this is 5 feet. So I'll use this formula PA because now this would be PA B square by L square, and this would be equal to PB square A by L square, PB A square by L square. This length is 15, L would be 15, A is 10. So A is 10, B is 5. So I have found out this. For this case, I have a UDL here, and the magnitude of UDL is 2 kip per foot, and it is acting at 20 feet. So this would be WL square by 12. So 2 into 20 square divided by 12, and it comes out to be 66.66. The load are balanced. 2 into 20 gives us 40, so this is 20 into 20, and you can find these reactions very easily. I'm finding this reaction, so I'll be doing RA into this length is, taking all moments here, RA into 15 minus 10 into the distance is 10 into 5 is equal to 0. And what if I remove this and make it like this? So RA would be equal to 10 into 5 by 15, and it comes out to be 3, and in total it is 3.33. RA into 15 minus 10 into 5, 50 divided by 15. 50 divided by 15 comes out to be this is wrong. I think I have to incorporate this moment as well. I haven't incorporated this moment. It's very easy. This concept is very important, and I have to compute this. This reaction has to be computed. For example, I'm interested in this. Okay, I have to find all moments here. This is anti, so minus 11.11.11, sorry, plus I don't know this. This is RA. So plus RA into 15 and minus 10 into 5 equals to, and then this is, yes, plus 22.2, and you have to find now. So it comes out to be, I have the calculator, 22.22 plus 50 plus 11.11 divided by 15. Yes, it is 2.60. So it is 2.60. It comes out to be 2.60, and then 10 minus 2.60, and you would be able to find this reaction as 8 point something. Why haven't written this? I mean, this is mistake or what? There should be some reaction here, and that should be 8.40. That should be 8.40. So I haven't written it. uh, this is mistake. I mean, it should be written here. The reactions should be here, 8.40. Wait a minute. Why I haven't written this, and I'm just recalling that why I haven't written this. 5 into 5. Okay, this is 10, and this is there must be some. I should have written that, but I haven't written it. That is 8.40. Okay, this is my mistake. So there should be 8.40 written there. I'm actually seeing my lecture because I haven't written that. So I'm very sorry for that. 8.40 should be there, and I haven't written that. This is mistake on my part. So you can write it. So there should be a reaction 8.40, and that can be easily found out. Thing is, while finding these reaction, you have to incorporate this moment and this moment. Okay, ideal matrix. I've constructed the ideal matrix. The ideal matrix should be corresponding to this. The basic concepts are similar to BSc, as the questions taught to you in BSc. Just it's in 3D and no other thing. I mean, it's in 3D, and that is all, and no other thing. Okay, D1. Corresponding to D1, I have yes, this reaction. You know, this reaction is 10, so this reaction would be equal to 10 minus 2.60 gives us 7.40. It's upward. Its magnitude is 7.40. Now, this 7.40 plus 20 gives us 27.40. It is equal and equal to opposite to D1, so that's why it's minus 27.40. So there should be 7.40 here. This vertical, this 10 is balanced here. Okay, finally I have next I have 66.66 corresponding to D2. So that's why this is here, the same direction. D3, 22.22. This is in this direction. This 22.22 is in opposite, so it's minus. So ADL is constructed. Okay, next I have to apply one by one these degree of freedom, and I have to compute. Now when I am applying, I am giving it a translation in this direction. So the deformed shape would be like this, and this would be equal to, okay, there is no, like if it was a frame and if you are giving an axial deformation, it would have been E by L, but there is no member in y direction, therefore no EA by L, no axial rigidity. But if there was a column here, like in a space frame, then we would have written EA by L. Okay, and this would be like this, and this would be balanced here. This should be balanced here. The magnitude should be equal to 6. Okay, there's only one EI, no EIX, no EY, no EIZ as in the frame. So E6, this should be equal to, when you give translation, it should be equal to 12 EI by L cube. And this should be 12 EI by L cube. So the L is different here. This is 20 and this is 15. So this is 15, so it becomes 12 into 15 divided by, 12 into EI divided by 15 cube. And it would be same for this. Here it would become 12 EI divided by L is 20. So 20 cube, and it would be same as that. So this is easy. Now in the next stage, and we have find the values. The value comes out to be this. Now, as it is forming a clockwise moment here, so I have to apply a resistive like this. This is forming a clockwise moment here, so I have to apply a resistive moment. So the magnitude of this moment would be equal to 6 ei by l square. 6 divided by 15 square. So 6 by 15 square is 0.0266. 0.0266. Now see the other span. Look for other span. This is forming an anti-clockwise moment. This is in z, this is in y, and this is in z, y, x. There would be anti-clockwise, so I have to apply a clock resistive. This is forming an anti-clockwise moment, so resistive would be clock. So direction would be same. 6 ei by l square. 6 ei by l square. Now 6 ei is okay constant, l is 20 square, so it would come out to be 0.015 and this would be 0.015. So in this way you would be able to construct this beautiful figure. This is dirty or I mean untidy, but using pen pencil you would be drawing it very neat. Okay, the thing is, look for the directions of d1 and what is my d1, what is my d2, and what is my d3, and this is very important. d1 is this vertical, d2 is in x, and d3 is in z. Okay, corresponding, if I have to find now in this case, because this is 3 cross 3 matrix, S would be 3 cross 3, so I will have 1 1, S2 1, and S3 1. Because d1 is equal to 1, so the second number would be 1 always. 1 is vertical, I mean if I draw the legend here, so d1 is like this, and d2 is in x direction and d3 is in the z direction. This is your d2 and this is my d3. Okay, as for corresponding to d1 you have this, so you have to add 12 ei by l cube, 12 ei by l cube, because the two spans are different, so l values would be different, so it comes out to be add this and this. So I have added this, so it comes out to be this. d2 is in moment in x, so correspondingly I have this, but it is opposite to that. The direction which I have taken, it is anti and this is clock, so it comes out to be minus 0.015. And S31, yes, this one, I have 0.0266, and it comes out to be same direction. Okay, this is done. I'm not going to do D2, and let me go to directly to D3, because D2 and D3 are same. So I'm gonna do D3 and I'm gonna draw it very beautifully like this and very sparsely so that it's understandable. So I am giving because D3 is in this direction, you should know D3 is in this direction. Okay, now if I am giving a rotation in Z direction, it will become a torsion for this member. Its magnitude would be equal to Gj by L. In this question, Gj is taken as 0.8 EI. So 0.8 EI and its length is 20. It become 0.04. It would be resisted somewhere here. But there would be a moment here, and the magnitude of this moment would be equal to 4 EI by L. Means 4 EI, the length of this is 15, and it comes out to be 0.266. No need to find this, just divide 0.266 divided by 2.133. Done. Finally, this is NT, this is X, this is NT in Z. So it should be like this. It is forming a clockwise moment here. This is anti-applied. Just balance it with this. These two would be same in the magnitude, and its magnitude would be equal to 6 EI by L square. 6 EI, the length is 15 square, and it comes out to be 0.0266, and this would be equal to 0.0266. Done. Now I have to find, because this is 3 S3 and S3, 1 3, 1 is downward in y direction. This is, now remember, this is D1, this is D2 X, and D3 is in Z. Okay, here I have only this corresponding to D1. So S13 would be equal to 0.0266. S23, 2 is corresponding to X direction. In this direction I have no moment. It comes out to be 0. S33 is the moment or rotation or degree of freedom in Z direction, right? So here I have this Gj by L, whose magnitude is 0.04 plus the 4 EI by L, whose magnitude is equal to 0.266, and it comes out to be, you have to add these two values, and it comes out to be 0.30666. So I'm done. It's very easy. It's quite easy compared to space frame, but finally you can write in this form. Now you should remember, this is S11, this is S22, this is S33. Now this is S12, but S12, and it's S12, right? This is same as S21. S13 is same as S31, and S23 is equal to S32. Same, the values are same. You have to use this mathematical model, and finally I find out these values. The mathematical model is it's very easy, and you have been the mathematical model is this. D is equal to always S inverse first, AD minus ADL. Using calculator or Excel, you can find this inverse. AD is 0, so it comes out to be minus ADL. So I have found out D value. Finally, this AM matrix, this is another mathematical model. AM is equal to, what's this? You remember? EDL, AML. This is AML plus AMR, AMD into D. In flexibility matrix, it is AMR. This is AR. This is AM, and this is also AML. In flexibility, this is stiffness. D is found out. AML, I've done it, I've split it. This is AM1, AM2, AM3, AM4. AM5 are moments. These are member actions, are moments are taken separately, and vertical reactions are. Now just find this. You have this value. For original loading, you have these reactions: 2.6, 7.4, 20, and 20. How come this 2.6, 7.4, 20, 20? This is what? This is from stiffness matrix. While calculating stiffness matrix, you found out these value. I mean, for D1 is equal to 1, these values were found out. For D2 is equal to 1, this column was constructed. For D3 is equal to 1, this column was constructed. Now look for this. Watch out for this one. All values, look, 0.033, 0.03, 0.015, okay. Go back. This value. These are what AM1, AM2, AM3 and AM4 are all vertical reactions. AM1 is here, AM2 is here, AM3 is here, AM4 is here. So while constructing D1 is equal to 1, the vertical reaction is 0.0. The vertical reaction here is this, equal opposite to this. That's why it would be minus. This is opposite to this 0.0015. This is same upwards, and my AM is upward, so it would be plus 0.0015. It's very easy. I don't know what's what's letting you not understand this. For this, okay, I have taken, this is my AM1, this is my AM2, this is my AM3, and this is my AM4. So I am constructing AMD, and I am constructing the third column, D3. D2 has been constructed, D1 has been, so I am constructing the third column. The first value would be from here, 0.0266, and this is upward and this is upward, so 0.0266. Then comes this 2 value, and correspondingly I have this minus. Why I have to write here 0.0266 and minus 0.0266. Here I have no reaction, here I have no reaction, so these would be 0. This is D matrix. And finally, in the final structure, you have got these vertical loads. This is equal and opposite, so 0. This is 31.048, this is 18 point something, it comes out to be 50. It comes out to be 50. This is 50. The loading on structure is 2 into 20, 40 plus 10, 50. Okay, your calculations are right and correct. Here, the moments would be taken. So it's quite easy. This is ADL, or you can call it AML. It's one and the same thing, and it is from the original structure. Got it? Okay, I'm going to find this column, and this is for D3 is equal to 1. So I'll go back where D3 has been applied, this one. I'll clear all spaces, all the writings. It is like this and like this. I've taken all moments like this. 1, this moment has been taken as 2, this moment has been taken as 3, this moment has been taken as 4, right? 1, 2, 6, 7, sorry, 5, 6, 7, 8. Okay, doesn't matter. This is 5. This is, I have to select the pen. 5, 6, 7, and 8. Now, this is my reference member or reference structure. For D3, I have got 0.133, and it is same as that. So I am constructing this column. It comes out to be 0.133. Here it comes out to be corresponding to 6. I have got these two values. So net moment is 0.3066. Same direction, so 0.03, no sorry, 0.3066. 7 is 0. There is no moment here, no moment here, so other two will be 0. Hold on. You can do it for other values. For d2 is equal to 1, this column would be coming. For d1 is equal to 1, this column would be obtained. So it's very easy. I don't think so. I mean, you need some time to understand these concepts. These are very easy. The basic concepts are same as that of stiffness metric method that have been employed to 2D structures. So for 3D, it's also same. I'll be solving one more question on this grid, and that question would be left incomplete. I mean, and you have to complete as a part of your final exam. It's very easy. You'll have to give some time, and also I'm giving you much time to solve your at least 2 week time should be given to you, and you have to sit down and practice a lot. Eid vacations are also coming, so actually we have to finalize the result by 7th of August. So that's why I'm hurrying up so that we get enough or ample time to solve the final exam. Thank you.